Today, we're going to learn about solving equations with variables on each side. Solve for the variable's missing value. So what do you do when the variable in question is on both sides of the equation? An important property about variables is that you can subtract them from each other by subtracting the coefficients. For example here, you can actually subtract 2k from both sides of the equation. Because 4k and 2k both have k as the variable, you're allowed to perform this operation. So in this case, subtracting both sides by 2k would result in 2 plus 2k, which is equal to, this would be 0, and then we have 16. Now we can subtract 2 from both sides, and we get 2k is equal to 14. Now we can divide by 2, and we get k is equal to 7. And this is our answer. So what you might notice is that we removed k from the right-hand side by subtracting it, and we're left with k isolated on the left. The second one's a little more tricky, but let's first subtract 1 from both sides so that we can get rid of the 1 on the left-hand side. So we get x over 5 is equal to 3 over 5x plus 6. Now you might notice that both of these numbers here have a denominator of 5. How can we get rid of that? Let's multiply everything by 5. The left-hand side by 5 and the right-hand side by 5. So 5 times x over 5, that's going to be x. And then on this side, we have 3 over 5x times 5, which is equal to 3x. And then we have 6 times 5, which is 30. Now let's subtract 3x from both sides. We get negative 2x is equal to 30. And now we can divide by negative 2, and we end with x is equal to negative 15. Finally, we have 1.6d times 2 in parentheses 1.8d minus 5.4. So we're going to have to use the distributive property to simplify this expression. So it's 1.6d times 2 times 1.8d is 3.6d, and 2 times negative 5.4 is negative 10.8. Let's subtract both sides by negative 3.6d so that we can have d on just the left-hand side. So we have negative 2, d is equal to negative 10.8. And now we can divide by negative 2, and we have d is equal to 5.4. And so that's our answer.